Hello everyone, this is Basanta Mahato from Department of Electronics and Communication Engineering, IIMT College, Greater Noida. My today's discussion topic is embedded system and its utilization. So as the name suggested here, the utilization of embedded system, how it is utilized in our day-to-day life, how we use it. But before that, why embedded system? Why it is required, basically. So if you see this in our slides, everywhere we are using the embedded systems, the design, whether in the hospitals, in our electronics gadgets, in our toys, in the transportation, in domestic use homes, video games, everywhere. You see, like in the automotive industry, you see this car. Here is this car. This is having so much. It's a combination of all different type of modules within a single car. If you look at this application processing, we have the GPS, mobile phones, and for the radio, FM, DAB. Then for the fuel injection control, passenger environment control, AC, power, driver, security control, Airbus, everything is there. So these are the part of an embedded system. Yes, embedded systems span all aspects of modern life, and there are many examples of their use. You see in the biomedical instrumentation, a big use, X-ray, MRI, CT scan, patient monitoring, surgical machinery, everything comes under this. And in the communication itself, we use the cell phones. Yes, the cellular phone, then the cellular TV is there, TV terminals, receiver, video games, all are comes under this category. And that is the peripheral controller of a PC. Here I am using the my laptop. Here is the USB connector there. One is the driver. The CD driver is there, CD writer, everything. So disk driver control, LAN controller, all flash driver, hard disk driver, all under this. In the industry also, where robots are used, surveillance systems are there, testing machineries is there, motor control is there, robot systems, CNC, PLC, every machines is there. So these all comes under the category of embedded systems. And in the scientific instrument in the laboratory, so digital storage devices are there, CRT screens are there, spectrum analyzer, digital oscilloscope, handheld device, all comes in this category. So where the embedded system exists earlier? The question is, in the previous, is this kind of system earlier? Yes, the answer is yes. Popularly in that days, but they were at that time, they were designed through the microprocessor. If you have seen this microprocessor, unlike today's system, which are built on the microprocessor, but earlier it was microprocessors. But the limitation of that microprocessor is to everything gets connected to the externally by using the peripherals modules, peripheral blocks like 8255, 8257, 8259, etc. So the embedded system designed using microprocessor is not only complicated in design, but it also large in size. It's so bulky. At the same time, the speed of the microprocessor is also limited for high-end applications. The question is, why then microcontrollers? The answer is, it is tiny modules. It's a small module. That's why microcontrollers. A microcontroller is a single system or the chip where all the supporting module blocks are inside on a single chip. Has the following features: ALU is there, memory is there, EEPROM, RAM is there, input output port is there, ADC is there on this single chip. analog converter, circuitry for reset, switch, power up, serial programming, debugging, instruction decoder, timer, all these within a single chip. So that's why the system is so much efficient. Then what is inside an embedded system? So then what are the blocks inside an embedded system? So every embedded system consists of a hardware built with a board which is called CPU. This hardware also contains memory chip onto which the software is loaded. The operating system runs over the hardware and the application software runs above the operating system. But it is not necessarily that for every embedded system, you need to run an operating system. If you have our small application that then not required for the any kind of operating systems. But if we, in case we integrate the application, then we require the transfer of all entire software onto the memory chip. Then we require this operating systems. So this is the layer. This is the layer of basic embedded system. First one is the hardware, then operating system, and above all is the application software. Let's now see the details, various blocks of hardware and embedded system. So under the one is the CPU, another is the memory, input, output, communication port. So this is the blocks. Inside, we have the CPU, central processing is the brain of the embedded systems. Another is called input devices through which the data gets in, and through which output devices data goes throughout. So read-only memory and the random access memory through which we data stored and feed the data. Another is the application-specific circuitry. Another is communication interface. If we want to communicate this module to the other blocks, then communication interface will works. Yeah, features of an embedded system. So we have been studying the embedded system. So what embedded system is a very specific task. They can be programmed to different things. Embedded system have very limited resources, particularly the memory, because since it is meant for a very specific task, so it is limited resources. So generally they do not have secondary storage. So embedded system have to work against some deadlines. That means the job has to be done within the specific time. Has to be completed within a specific time. In some embedded system called the real-time embedded system, the deadlines are strict, very specific. Here you see, embedded system are constrained for power. Embedded system need to be highly reliable. Some embedded system have to operate extreme environment conditions. So these are to be taken care of. Embedded system that addresses the consumer market. So that means the cost is also to be taken care of. Unlike desktop computer, hardware platform is dominated by the company itself. So choosing the right platform is the complicated task. It's a complex task. So based on the functionality and the performance required, embedded systems are classified as standalone embedded system, real-time embedded system, network embedded system, and the mobile devices. So, like name suggested, standalone embedded system works in a standalone mode. Standalone. The input can be electrical from transducer and the command from a human being, such as pressing of a button. The output can be electrical signal to drive another signal. So LED may be displayed or the on. So embedded system in process control, automobiles, consumer. all are of like based on in the process control, automation, consumer electrical fall into this category. Then embedded system in which some specific work has to be done in the specific time period. These are comes under a real-time embedded system. So within a certain time, fixed time, the work has to be done. If it is not there within that time, maybe many catastrophe may be occur. Like let's say an example, if a valve is not open within the 30 millisecond, let's say time defined earlier, so it may be possible some mishappening must be maybe there. So in such cases, a strict deadline are called hard real time. Another in the system, where in the system in some system where a deadline in some systems deadlines are imposed but not adhered to them in a while may not lead to a catastrophe, may not happen. Let's say example, consider a DVD player and we want to command giving to open the DVD player from a remote control. If there is a delay to few milliseconds in executing that command, but that delay won't lead a serious implication. Such systems are called soft real-time systems. So here you see a hard real-time embedded system example. We have an aircraft and another is the missile. If the missile target to the aircraft, so the time must be given to that missile within that much of seconds or the millisecond, the aircraft has to be targeted. If it is not done within that particular threshold value, what will happen? The missile may target of the other place, or before the target, it catches fire. It catches fire. So process may not be task on the at that time particular time. So these comes under hard real-time embedded system. So embedded system that are provided with network interface and access by network. So networks are involved, and that comes under network information applications. Here is the examples, few examples. If you see, here is an example. Here is a computer as an internet and the weather monitoring system. So we are through the weather monitor and the getting the data, that data sent to the computer through the internet. And the internet through that's coming through the TCP/IP protocol suite, or may the display may be through the HTTP web server running on the system. A computer connected to the internet can access this system to obtain real-time weather monitoring information. So these comes under the networks. The network information application need to run the complete TCP/IP protocol stack, including the application layer protocol. If the application has to provide information over the internet, HTTP web server also need to run on the system. Another is called the mobile devices. Mobile means which is movable. So mobile devices such as mobile phones, personal digital assistant PDAs, smartphones, etc. are a special category of embedded system. So these comes under mobile device embedded system. Mobile. So limitation of the mobile devices are, it's a memory constraint, small in size, lack of good user interface. So these are hence mobile devices are considered as embedded system, but with some limitations. So language, what kind of language are used in the embedded system? The first one is the assembly are the most pioneer, because assembly language are also called the machine level. So that means we can directly give command to the machines or the systems. More prominent. But the presence of tools to the modern softwares in the UML or HTML in the so sufficient to indicate the maturity of embedded system program. So right now, most of the embedded systems run on the language that is called C, approx 45%. Again, the advancement of C is the C++, increasing that object-oriented methodology benefits done through the C++. But the C is very close to the assembly programming, and it allows very easy access to underlying the hardware. A huge number of high-quality compiler and debugging tools are available for the C language. Right? So C language can definitely claim the more maturity compiler than the C++. Another is the most popular one, that is called embedded C, C++. So what are the communication interfaces in the embedded system? So for embedded system, interfacing means to the outer peripheral. One is through the serial communication interface SCI, that is through RS-232, RS-422, RS-485. So synchronous serial communication interface, I2C, JTAG, SPI, and another is called universal serial bus. This is so popular in nowadays. Everywhere we are using the term is called the USB. So pen drive, we have the USB in our charging plug. If the data transfer or the data getting through the our that cell phone, that we use the USB. USB is more faster than. In the network, we have the Ethernet, controller, LAN, etc. The type for the timer, PLL is there. Capture, compare, and the time processing unit is there. General purpose GPIO, analog to digital converter, digital to analog converters are there. Then the question is always minds. Then we are talking about the design aspects, how we design the embedded systems. Here is which is the best suited microcontroller for design of embedded system. There is always a trade-off between efficiency and power dissipation. To know this, let us review the various types of microcontrollers and their specific vendors. So this is a types of microcontrollers. It is a 8-bit, 16-bit, or the 32 bits. Then memory devices, embedded or the external memory. Instruction set, type of RISC or the CISC. And memory, what type of architecture is there, hardware and the Princeton. Then family of a class of the microcontroller, 8051, and the PIC, Texas, ARM, or others. And these are the vendors' name: Intel, Philips, Atmel, Siemens. From the previous slides, we can find that ARM processor is a strong option for the better performance. But being as a designer, we will look into another parameters also. In the case of power consumption. So in case of power consumption of ARM is 400 milliwatt. But in case of Atmega, AVR microcontroller consumes low power, 16.5, but provides low performance. But in TI MSP 430, the range is only 1.2 milliwatt with reasonably good performance. So it is always left to the designer to choose a suitable device according to the requirement, means according to the application. So let us to design an embedded system. It's a kind of case study. To understand the design of a simple embedded system, let us first consider the idea of data acquisition, how we collect the data and the store of that. So data collection system is through the next. So we need the data, means always the data is in the physical state, physical condition. So that is done through the sensor. Sensor takes the signal through the sensor, and that the value is again transduced. That means the translate that data through the transducer, and that transducer data is analog form, and that is converted. It is continuous basically, but next then converted it to analog to digital converter, because our processor is the digital signal. It takes digital signal. So ADC converts the signal to the digital, and that goes to the processor. So processor process the signal according to the application or according to the program specified, and that converts to the digital DAC, and finally goes to the output, because output data always analog or the user defined user understandable language or understandable value. Then the DAC converted the through digital to analog. This is a complete system of. So first must be select the temperature. The sensor is the LM35 or AD5. So these are the analog sensors, temperature sensor, through which temperature has to be taken. So after that, analog data is converted into digital. At the same time, proper signal conditioning is done. So this is done through the fed into the microcontroller, where we program it through embedded C or the assembly. For this purpose, for the programming purpose, Keel or RIDE or ARM embedded bench or the C compiler can be used. Once the program is debugged and found error-free, it can be dumped into microcontroller through the flash. Now your microcontroller chip acts as an embedded chip. So this is the complete block diagram. We have chosen the LM35 sensors, and we have chosen the microprocessor, microcontroller as a ARM processor. ARM7 we use, and inside the ARM ADC block is there, and for the display graphic LCD is there. And suppose we want to that our output device here is the motor with the fan. So since the motor is the DC motor, and that motor power for the driving power is too much, so the controller has to be drive the signal for the motor one. So we need a driver. So here is the pin configuration with sensor and the different modules. Here is the sensor, another is LPC ARM processor, and through this motor device, motor driver for the driving of the motor, and if the values may be high or the low, accordingly a buzzer may be fitted. So for the embedded C software, you can download through this. You can get it from Keel Mu Vision evaluation version. Embedded C compiler can be downloaded free from this. Embedded IR also available. So various vendors are there. These are the vendors through which we can get the microcontroller kit. We can purchase it on a reasonable price. And books that helps to understand the embedded systems. Basically, Rajkamal, it's a very good book for the new one, and volume 1, volume 2, and there is edition, second edition, third edition. So these are very good book, TMH publications. And Mazidi and Mazidi is a very understandable book for 8051, and AVR for AVR microcontroller with embedded system also available on the market, and good for the basic beginners designer. So there is an architecture programming, again the Rajkamal, microcontroller architecture programming, Pearson publication. Then Frank White, embedded system, unique hardware software introduction with the ARM. It's a good book. So, and these are the website references through which we get the informations of the embedded system design and the design aspects and the programming. These all you'll get it from here. These are the projects. So there's a lot of to learn, but there is a basic understanding to build, just a small matter of getting experience. So till now, we have what you conclude in this mark. So we learned that what embedded system is. Finally, we can say embedded system is designed for a very specific task. So we design through a microcontroller. Then, so that means if our application is to be chosen, so accordingly we choose the microcontroller. If our microcontroller application is very big, on that case we choose that type of controller who having memory that much of, need more memory, or we add some additional memory, like. Then types, types of the types of embedded system we learn, like real time, hard real time, soft real time, and we have given also the examples that and design aspects, how we design. That means our design has to be by the 8 bits, 16 bit, or the 32 bits. If we want to our device make it faster, then we choose the higher bits or the higher bits. If we need our systems to be more less power consuming, then accordingly we choose like MSP 430 or that type of AVR, like. So controller selection is also part of this. And finally, the language selection. Language is also a part of time consuming, because our step size and the machine cycle, and overall the time taken by to fetch and execute the complete program. So language selection is also a big factor to design an embedded system. So overall, here we see the design of an embedded system. So overall, we can say embedded system and its utilization is a big issue in current in nowadays. So everywhere we are playing with the now we can say we are playing with the embedded systems, but how to design it, that we have given in this my today's talk. Okay. Thank you. So here, it is any device that can include a programmable computer, but it is not sufficient intent to be general purpose computer. So they are the engineers, they code the things. Embedded system or the electronic system that contain a microprocessor or a controller, but we do not think of them as computer. The computer is a hidden embedded in the system. Okay. Thank you.